Next problem is obtain the shortest distance of the point 1, 2, minus 3 from the plane 2x minus 3y plus 6z is equal to 20. Let x, y, z be the any point on this plane. Now, what do we have? Therefore, 2x minus 3y plus 6z is equal to 20. That is, this point satisfies the equation because it lies on the plane. And then let d is the distance of this point 1, 2, minus 3 and x, y, z. That is root. What is the distance is what? Root x minus 1 square plus y minus 2 square plus z minus minus plus 3. Right here, plus 3, because the point is 1, 2, minus 3. So right here, plus 3, x plus 3. The point is 1, 2, minus 3. If the point is 1, 2, 3, then this answer is correct. So it is point, I think it is point 1, 2, minus 3. If there is minus 3, then write. If there is plus 3, then write this z minus 3. So this is the distance. Okay, this the distance of this point from the point xyz which lies on the plane this. Okay, and we have to remains this d as constant, d as minimum, shortest. That is, we have to find the shortest distance of point from the plane. That is, if we take if you what find the perpendicular distance of this point from this plane. Perpendicular distance of the point from the plane means the shortest distance. So suppose x, y, z be any point on this plane and the distance of this plane. Now we have to remains this d as a shortest minimum, and instead of the d remains shortest, we can also remains d square as shortest or minimum. If d square is minimum, then d is also minimum. D is always minimum. Okay. If d square is minimum, then automatically d becomes a minimum. So we in order to simplification of the calculation, in order to further calculation, instead of d we remains d square constant. That's why we find derivatives of this quantity with respect to x, y, z easily. uh, if there is root sign, then derivative is what? 1 by 2 time root of this quantity and into derivative of this quantity with respect to x, y, z. That's becomes complicated. So in order to cancel the root, squaring both sides. So we had to remains this d as a minimum. So instead of that, we remains d square minimum. If d square is minimum, then automatically d becomes minimum. D is minimum for that values of x, y, z. So we denote this function by f x, y, z. That is, we have to find the minimum value of this function f x, y, z. And so the condition is what? This is the condition that phi x, y, z is what? 2x minus 3y plus 6z minus 20, 0. Then we construct the auxiliary function capital F is equal to small f plus lambda into phi. That is, this is the small f plus lambda into psi. Phi is this small f plus phi lambda into phi. Okay, is equal to 0. Take is equal to 0 or don't take is equal to 0. Is star, and differentiate partially with respect to x, y, z lambda and equating with 0. So we have this. Okay, equation number 1, 2, 3, 4. Obviously, equation number 4 is the given condition. And then from equation number we have the value of x. We have the value of from equation number 2 we have the value of y free from in terms of lambda. Then find the value of z from equation 3 and substitute in equation number 4. This is the first procedure. Okay, this is the first procedure, that is find the values of x, y, z from equation number 1, 2, 3, 4 and substitute in equation number 4. So we have the value of lambda, and then substitute that lambda in the equation number in these values of x, y, z. We get the values of x, y, z. Okay, so I think here some wrong procedure is applied. So this process, instead of this process, what is the next process. Find the value of x from equation number 1, find the value of y from equation number 2, z from equation number 3, and then substitute in the equation number 4. We get the value of x, y, z. We get the value of lambda, and that value of lambda substitute in the equation number that the values of x, y, z. Okay, so this is the actually the first procedure of solving the problems by Lagrange's method. Here is the again the same answer of the same problem. So this is point is 1, 2, 3. Then this is correct, that let x, y, z be point on the plane, and then the distance of that point on the plane and this, and we have to remains this d as a minimum. That's why we squaring both sides, and then fx, y, z, and then auxiliary function, and then yes, here is the procedure is correct now. That equation number 1, find the value of x, then y from equation number 3, and z, and then substitute this equation number 4. We have the value of lambda is minus 84 by 49. Then x is 1 minus lambda, so we have the answer 133 by 49. Y is again, y is this, substitute y, lambda, we have the y, and then we have the z. Okay, and then uh, at, this is the required point, that is x, y, z. So this is the shortest distance, d is 36. So find the shortest distance. What is the question? Obtain the shortest distance of this from, and therefore this is the point from which the distance of the point 1, 2, 3 is minimum. What is that point? Write the x, y, z value of x, y, z in round bracket 133 by 49, comma y value of y, comma value of z. Okay, and then the distance of the point 1, 2, 3 from this, that is right, this the d is equal to write the value of x, y, z as these values. So we have the answer 6, and this is the shortest distance of the point from the plane. Same type problem, show that the shortest distance of ABC from this plane is this. Same procedure, that is first take the point xyz on this plane, xyz be any point on this plane, then it satisfies the equation. We have ax plus by plus cz plus d is equal to 0. This is the pi. Now pi, this is pi, LHS is pi, and then suppose d is what, distance of the point ABC from the point xyz. Okay, that is root d is what, root x minus a bracket square plus y minus b bracket square plus z minus c bracket square. Okay, and then d square is x minus a bracket square, y minus b bracket square, z minus c bracket square, that is fxyz, and pi xyz is what, ax plus by plus cz plus d is equal to 0. Then we construct the auxiliary function capital X equals small f plus lambda into pi, that is x minus a bracket square. Instead of d, we write d square here. Okay, means in order to minimize d, we minimize d square. Okay, right, find the value as a function fxyz. D square is the function fxyz. So lambda ax plus by plus cz plus d is equal to 0, and then partially differentiate with respect to xyz. All the procedure is same. Then find the values of xyz in terms of lambda, and then substitute in equation number 4. We get the value of lambda, and substitute that value in this. We have the xyz, and then substitute xyz in this. D square is equal to d is equal to what, root, d is root x minus a bracket square, y minus b bracket square, z minus c bracket square. Substitute that values, we get the answer, this answer. Okay, or some short method is there. We discuss this answer of this problem in the some another extra problems for extreme values. Some more problems on the extreme values. We have to increase its size. Okay. So the problem is what? That problem, find the shortest distance of the point ABC from the plane. So this is the shortest distance of the point from point ABC from this plane is this. Okay, so we construct, let x, y, z be any point on the plane. We have this ax plus by plus cz plus d is equal to 0. The distance of x, y, z and ABC is this. Then d square is this. Find the we construct the auxiliary function capital F is equal to small f plus lambda into pi. Then differentiate partially with respect to x, y, z, lambda and equal to 0. We get these equations. Then multiplying equation 1, 2, 3 by that is find the values of x, y, z from equation 1, 2, 3 and substitute in equation number 4, find value of lambda. This procedure is applicable, or this is another procedure, multiplying equation 1, 2, 3 by x minus a, y minus b, z minus c. We have this, and adding these three equations, we have this bracket, that is the value of x minus a bracket square, take 2 as common, and the value of this bracket square is d square, and then this we have 2d square is equal, lambda is equal to 2d square by a plus bb plus cc. Okay, calculation of this, ax plus by plus cz is d plus d. Okay, so we have take is minus d cap minus capital D. Okay, and then take a minus sign as common, we have this lambda is equal to this. So and then putting this lambda in equation number 1, we get x minus 2x, lambda is equal to x is this, and similarly y is this, z is this, and therefore the critical point is this x, y, z. Okay, which is the point of minimum. Okay, and then write that x, y, z at these places, d square. So we, after calculation of this, is what, this is LCM, and then take d square as common minus d square as common. So a square plus b square plus c square, bracket, actually this is bracket square, that's why we have d raised to 4 at this place, d raised to 4, d square is d raised to 4 a square. So right here d raised to 4, and then what do we have here is d square. Okay, here is d square, and here d raised to 4, and d square, if you shift d square to right side, then we have d raised to 4 by d square. Here is 1, d raised to 4 by d square is d square. Then shift this d square to right side, so change the numerator and denominator. We have this answer, and then d is mod of taking a root of both sides. So this is the procedure, another procedure. Okay, that is d is this, or this first procedure is what, find the values of x, y, z from equation number 1, 2, 3 and substitute in equation number 4. Actually this is the procedure. Okay, so some another problems, this is also solved in the previous lecture. Instead of +3, there is here is -3. So find the shortest distance of the point from this plane. So suppose the point P x y z b lies on the plane. Therefore, we have this equation is satisfied. Therefore, this is the condition. Pi x y z is what, 2x minus 3y. That is x y z is the required point. Suppose the point on the plane. Then we have this, and then the distance of the point x y z from this point 1, 2, minus 3 is what? Actually d root x minus 1 square, y minus 2 square plus z plus 3 bracket square. Okay, z minus 3 become plus 3 bracket square is this. Actually d is in a root, but d square is then what, take square of both sides. and this is fxyz, and which is to be minimized. That is, we have to find the minimum value of fxyz, for which this function is minimum. We have to find the value of xyz for which this function fxyz is minimum. Actually, we have to uh, remains this d as minimum, but if we find the value of xyz for which d square is minimum, then automatically d is minimum. So construct the auxiliary function, okay, small f plus lambda into phi, and this is the function. Then differentiate with respect to x, y, z lambda, and equating with 0, we get 1, 2, 3, equation 4. And then this is the procedure actually is applicable, or find the values of x, y, z. In the previous lecture, we will observe that the values of x, y, z, find the values of x, y, z from equation 1, 2, 3, substitute in 4, find the value of lambda, and then we have the values of x, y, z. Or this is the another procedure is also applicable for the problem capital Ax plus by plus cz plus d is equal to 0. General problem. That is multiplying the equation 1, 2, 3 by x minus 1, y minus 2, and z plus 3, and we get 5, 6, 7. Adding this, we get the value of lambda. And substitute this value of lambda in equation number 5. We get in equation 5 or in equation 1, we get the value of x minus 1, y minus 2, z plus 3 in equation 1, 2, 3. And then d square is what? D square is what? That is x minus 1 square plus y minus 2 square plus z plus 3 square, bracket square, is what? Is equal to d square by 21 bracket square, and the value of x minus 1 square plus y minus 2 square plus z minus 3 square is actually d square. So write d square is equal to x minus 1 square plus y minus 2 square plus z minus 3 square, and then is equal to, next step is what? X minus 1 is d square by 21 its square, y minus 2 is this its square, then z plus 3 is this square. And so solving this equation, we get this d is 6, the shortest distance. And same problem is solved by previous method, another method in the previous lecture. Find the greatest and smallest value of the function fxy is equal to xy. Text on the ellipse, this, that is, the condition is given and the function is two variable function, but the condition is given. So apply the Lagrange's method of undetermined coefficient, that is, construct the auxiliary function. Don't use this method, use the Lagrange's method, that is, this is the condition phi xy, this is phi xy, this condition is denoted by phi xy, phi, and this is small f, x into y. Then construct the auxiliary function capital F is equal to small f plus lambda into this condition, and then differentiate with respect to x, y, z lambda, equating with 0. That are the equation number 1, 2, 3, 4. Then apply the procedure and find the value of x, y, z. So don't use this method, use the previous method. So these are some problems for exercise. These are two variable problems. So these are solvable solved by using second derivative test. That is, find small x, small fx, fy, partial derivative with respect to x and y. Then equate with 0. That is, consider the equation fx is equal to 0 and fy is equal to 0. Find critical points, that is stationary points, and then find from second order derivative. Find capital A, capital B, capital C, and then delta, and then write the nature of that function at that point. Okay, so these are actually the two variable functions, and conditions are not given, so apply the second order derivative test. Okay, this is the second two variable function, but condition is given, so apply Lagrange's for this problem number 2 to find the extreme values. Apply Lagrange's method of undetermined coefficients. For this, apply second order derivative test, and these are also the same problems, extreme values problems, but conditions are given, two variable function or three variable functions, and conditions are given. So this exercise number 2 is on the Lagrange's method of undetermined coefficients, and these are the problems on the second order derivative test. So solve all these problems. Again, the same problem is here. Solve all these problems, and in the our assignment notebook, solve all these problems. So these are some another problems, solve problems. R square is this, okay, and this is the condition, and where to find the minimum value of R. So instead of R, we will find the minimum value of R square. If R square is minimum, then automatically R becomes minimum. So don't write R as a root x square plus y square plus z square here, because it becomes complicated for further calculation. So instead of R, we write R square here. R square, that is the small f plus lambda into condition, and then differentiate with respect to x, y, z lambda and equating with 0. Same procedure. And we have the values of x, y, z from equation number 1, 2, 3 in terms of lambda, so that we apply the first method, that is find x, y, z in terms of lambda from 1 to 3, and substitute in equation number 4, we get the value of lambda, and again we have the values of lambda x, y, z from the these equations. Okay, this is one procedure. Or multiplying with by x, y, z and adding, we get the value of lambda, and then substitute lambda in equation number 5, 6, 7, we get the value of x, y, z. Apply any one procedure. Both the two procedures are applicable for this example. Okay, so we have x, y, and z. R square is this, and then x, y, z is what? 20, 20, and 20. Okay, so this answer of this problem is what? Find the values of x, y, z for which R is minimum. So R is minimum if x is 20, y is 20, and z is 20. If x, y, z are positive and this is equal to 1, show that the minimum value of x plus y plus z is this. Okay, so the condition, we have to find the minimum value of x plus y plus z. So denote x plus y plus z as fxyz, and this is the condition. Then capital F is equal to small f plus lambda into condition. Condition is what? This minus 1. Okay, then differentiate with respect to x, y, z lambda and equating with 0, and then apply one of the procedure, that is we have the values of x, y, z from equation number 1, 2, 3 in terms of lambda, and then substitute in equation number 4 and find value of lambda, and then we have the x, y, z. This is the procedure number 1. So for this problem, the procedure number 1 and procedure number 2 both are applicable. So here is the procedure number 2, method number 2, that is multiplying equation 1, 2, 3 by x, y, z, that are 5, 6, 7. Adding 5, 6, 7, we have lambda. Again substitute lambda in equation number 5, 6, 7, we get these values. Okay, x, y. Actually we get the values of x, y, z, but we have the x in bracket x plus y plus z is equal to a square, and then adding this equation number, all these equations. So we have x plus y plus z as common, and then we have x plus y plus z is equal to a square plus b square plus c square, and therefore its square is this, and therefore x plus y plus z is root a square. This is shortcut to find the value of x plus y plus z, minimum value of x plus y plus z. Or the another procedure is what? By substituting lambda in equation number 5, 6, 7, we get x is a square by x plus y plus z, y and z, and then by using conditions number 6, this condition, we have the value of x plus y plus z is equal to this. This problem is already discussed. So these are some exercise problems for homework on Lagrange's method of undetermined multipliers. So solve all these problems. These are answers of the problems. So solve all these problems in your assignment notebook. So here the extreme values chapter is over. The next chapter, last chapter, is multiple integrals, that is double integral, triple integral, we will see in the next lecture.